So we need to use the definition of a Taylor or Maclaurin series to find the first four non-zero terms of the Taylor series for the given function centered at A. We also need to write the power series using some summation notation, and we need to determine the interval of convergence of this series. So a Maclaurin series is given by the following formula: f of x equals the sum from k equals 0 to infinity of k's order derivative of f of a over k factorial multiplied by x to the power of k. So in our case, f of x equals sum p of x, which equals the sum from k equals 0 to n of k's order derivative of f of a over k factorial times x to the power of k. But since we need to find only first four terms, we can rewrite this as the sum from k equals 0 to 4 of f to the k's order derivative of f of a over k factorial times x to the power of k. So what we need to do now is to find the derivatives and evaluate them at the given point. So first we start by finding f prime of x. It equals, let me write, f of x equals e to the power of negative x. Then f prime of x equals negative e to the power of negative x. Then the second order derivative of f of x equals e to the power of negative x. Then the third order derivative of f of x equals negative e to the power of negative x. And the fourth order derivative of f of x equals e to the power of negative x. Now we need to find the values of these derivatives at point A. So at point x equals 0, then f of 0 equals 1, then f prime of 0 equals negative 1. Then as a second order derivative of f of 0 equals 1, then the third order derivative of f of 0 equals negative 1, and the fourth order derivative of f of 0 equals 1. Now we just substitute the values to get a polynomial, and we get that f of x equals x plus negative 1 over 1 factorial times x plus 1. Oh, sorry, here I made a mistake, my bad. So here we have 1 over 0 factorial times x to the power of 0 plus negative 1 over 1 factorial times x plus 1 over 2 factorial times x squared plus 1 over 3, negative 1 over 3 factorial times x cubed plus 1 over 4 factorial times x to the fourth power. And then this equals 1 minus x plus 1 over 2x squared minus 1 over 6x cubed plus 1 over 24x to the fourth power. So this is our answer to part A. These are the first term of the Taylor of the Maclaurin expansions of the given series. Now let's do part B. Here we need to use summation notation. Then f of x equals the sum from k equals 0 to infinity of negative 1 to the power of k times 1 over k factorial times x to the power of k. And finally, we need to determine the interval of convergence of the series. We will use the ratio test here. So we know that we know that an, so nth term of the series equals x to the power of k over k factorial. Then L equals limit of the absolute value of a n plus 1 over, oh sorry, here we have k, a k plus 1 over a k, where k approaches infinity, then this equals the limit of the absolute value of x to the power of k plus 1 over k plus 1 factorial divided by x to the power of k over k factorial. And k approaches infinity. Then this equals limit of the absolute value of x over k plus 1, where k approaches infinity, and then this equals 0. That means that we know that 0 is less than 1, so that means that this series converges for all value of x. Then the interval